Yeah.
Okay, so in the last class, Vishnu, in the like we have actually discussed the basic portion of the thermodynamic, basic introduction one, basic definitive terms. Okay, today we are going to start the work done. Okay, so work done in a reversible process. So if you have a, if anything which is doing a work, okay, work done in reversible process, I'm talking about. So reversible one, suppose if you have a piston. So if I have piston, I mean it's a tank, that is your piston, which can move up and down. Okay,
Hmm.
that is the thing. Okay, and there is some liquid in that. So if there is some liquid in that, suppose something, some pressure is there inside the liquid, some
Yeah.
pressure. So because of that, some pressure, or maybe some liquid is there. So actually, it's a pressure which is like internal pressure. But you are applying some outer pressure. You are
Hmm.
applying, like you are pushing it. You are applying pressure which is the external one. So when you
Yeah.
are applying external pressure, so obviously liquid also have some internal pressure, internal
Yeah.
one. Okay, you are trying to suppress that. Okay, so after some time, suppose your piston reach to this side. So it means some of the portion you have compressed, yes or no? Some of
Hmm.
the portion, because you have just changed the volume. So can we say it is a delta volume or dV? Whenever there is a change in small volume, na, so you will always say delta volume or the dV.
Hmm.
Delta volume means either you will say delta V or you will say dV. It is the same
Yeah.
thing. Okay. And remember always work done is equal to P into V. Okay.
Hmm.
Pressure into volume is also called the work done. So you are like there is a frictionless piston and there is a cylinder. Cylinder is fitted with this frictionless piston. You need to remember that. So now you are allowing this gas to undergo a very small expansion, you can say, like against the external pressure. So yes, there is some external pressure, there is some internal pressure. Okay, so there is a change, you can say it's a small volume. So now when I say there is a like work done, if I want to find out the how much work done it has done, how much work done, so I will say small work done, dw. Dw means work done, small work done. It is equal to minus ka p external into dv. Pressure remain the same, small work done means small volume change. If you are doing a small work done, so obviously change will also be small. Okay, remember that. But you should know one thing. You should know one thing. P external is actually equal to P internal minus ka dp. It is basically for the reversible process. Why is it so? P external is actually P internal minus ka dv. dp. What does it mean?
What's DP again?
dp is actually the pressure for the small one, this one, dp.
Isn't that DV?
Yeah, volume is dv. Volume
Oh.
is dv. I am talking about only the pressure one, the
Hmm.
pressure only. Okay. Just if you are getting doubt here, so you don't need to see that. Okay, so actually we have just find out the dw is equal to the p pressure or into my dv. You don't need to see that. Okay, you don't need to see that. Just remember, work done is equal to the pressure into volume, nothing else. Actually it's a formula, but actually I'm trying to solve it. So if it is a p into dv, but you want to find out the complete work done, suppose we have just seen the small situation, but you want a complete work done. So for complete work done you have to do the integration. Do you know how to do the integration? Have you studied that before?
No, I haven't. But teach me.
Oh, okay. Okay, fine. Actually, suppose there is a small change in the volume, but suppose initial volume was V1 and the final volume is V2. So it means complete change is occurring from volume V1 to the volume V2. So you will take V1 to V2. These are known as the limits. Don't worry, I will take a separate session for the integration and the differentiation, but as of
Okay.
now just see it. Okay, so it's a like minus like it's a pressure into dv. Minus sign I have already taken outside, you know it. Actually there is a equation which is known as a pv is equal to nrt. I will, when I teach you the gas constant, like gas laws, then I will tell you ideal gas equation is PV is equal to nRT. R means gas constant, N means number of moles, T means temperature, V means volume, P is pressure. So PV is equal to nRT. If PV is equal to nRT, so we can say P is equal to nRT upon V. Can we say
Yeah.
that? So
Yeah.
can I put the value here? Of course we can. So V1 to V2 it is going. P means, so in the place of P we can write that nRT upon V. So P is equal to nRT upon V, right? And it becomes
Yeah.
the dV. Okay. So here nRT is a complete constant. nRT is complete constant. So here
Okay.
so constant term always come ahead. So this is the constant term, it is coming ahead, and now integration is only done to the variable part. So I am
So
doing
V.
the, yeah, so which one is a variable part which is changing actually? So
V.
obviously, yeah. So it is the dv upon v, right?
Yeah.
And there was limits v1 to v2 it is going. So always we have to integrate first. So
Okay.
whenever there is a dv upon v, so it become the natural logarithm.
And I know
So
that.
okay,
I know that.
so dv upon v it will become the natural ln v. Ln v it will become, but there is a limit v2 minus v1. So whenever there is a limits na v2 upon v1, so you will apply final like minus nRT. You will put first value v2 and then v1. So it will
Mm.
become ln v2 minus ln v1. This is how we usually fill like upper limit minus lower limit. Like it is ln v na, so you will put v2 in place of v first and then minus v1 in place of v. So
Okay.
nRT ln v2 minus ln v1. This is how
Okay.
we have to put the limits. But remember there is a property of log. Whenever
Yeah.
anything is in minus ln v2 minus
You can
v1,
divide.
so
You
you
can
can,
divide.
yes, you can write it in division as well. So
So
you will say
V2 over V1.
minus nRT, it will become ln ln. You can directly write ln v2 minus v1. Okay, it has the
No,
same meaning.
that's V1 over V1. V2 over
Sorry,
V2.
sorry, 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 sorry. Yeah,
Yeah.
v2 upon v1. Okay,
Yeah. I'm pretty familiar with logarithms, just
very
not
good. And
not.
and it is the ln, it is the ln. But if I say log, so whenever you are
Big
converting ln to log, so you have to multiply by a number, right?
E
2.303.
E.
Yeah, 2.303 nRT, and it will become log v2
Yeah.
by v1. So this is your formula for the work done in a reversible process. Remember,
Yeah,
okay?
but natural log is so much easier than like
Yeah,
regular
yeah,
log.
yeah. You can say that. You can say that. But they can ask you anything, na? They can ask you
Yeah.
in log as well. That's why I had to tell that. Okay, so
Yeah.
that's
Okay.
why. So
You
this
you
what we have just done here. So we have just find out the work done in the isothermal process. Isothermal means when you are not changing the temperature, when your
temperature. Yeah.
temperature
Temperature
is
is
constant.
constant.
So this is your isothermal process, and it is reversible or the irreversible.
Irreversible because
No, no, no,
it's
reversible. It can come back as well. It is reversible process. So we have done this. We have studied this thing for the reversible process. Okay.
oh, so doesn't a piston do it fast, like very quickly?
Piston is, no, 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 no. Piston is doing a very slowly because it is done by itself. No, 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 no. As suppose anything can be there. Gas, suppose gas is expanding. Gas is automatically making the piston to go up. Gas is expanding. So it is going very slowly. So that's why temperature almost remain the constant. You are not
Oh,
changing it. Okay,
I
fine.
thought pistons went very fast.
It is depending on you. If
Yeah.
you apply a force very fast, So that then it will not be in this process isothermal. But if it is taking place by itself, then it is.
Yeah, I see.
Okay, so
Yeah.
you can consider that like you are not applying the force, actually that gas is expanding, and gas is expanding automatically. Okay, it is
Yeah.
making the things to go upward. Just remove that. Okay, external is also there, like atmospheric pressure is always there. In my head there is a atmospheric pressure as well, that is the external pressure. So suppose this gas is expanding with very slow rate, so temperature will remain the constant. It is a isothermal reversible process. So for the isothermal reversible process, you have to remember the formula: minus 2.303 nRT log v2 by v1. But there is a Bayes law, I guess I told you in the biology as well, right?
One second. Let me just write
Sure, sure,
the
sure, sure, sure.
nine that one down.
Okay, okay, fine. So there is a Bayes law as well, and Bayes law, one day I told you it is equal to PV is equal to constant.
Right. Yeah.
PV. So if PV is equal to constant, so so this is the final formula in terms of V2 and V1. But can you write this formula in terms of P1 and P2 as well? P1 and P2 as well, if you can.
Yeah. One second.
Yeah, firstly write down and then I will tell you.
Or
So integration is very simple. Just find out for the
for
small
this
one
one.
and then integrate it. After the integration, you will get the complete one.
Okay. So what was the question again?
Yes. So this formula just came in the terms of V2 and V1. But can you find out this formula in terms of P1 and P2? Yes, obviously. Why? Because we know that the Bayes law. Bayes law is what? Like P1 V1 is equal to P2 V2. We know that already. So if we
Yeah.
know already this formula, so it is the V2 by V1 now. So can you bring this V1 to right side and P2 this left side? Obviously. So
Yeah.
it will
Divide
become
them.
P1 by P2 is equal to V2 by V1, right?
Yeah.
So can I put this value here? So
Yeah.
this V2 by V1 automatically becomes the P1 by P2, right?
Yeah.
So you will get this formula in terms of pressure as well. nRT log P1 by P2. So now you have two formulas, this one and this one, right? Got it?
Yeah. Yeah.
So this process is basically for the expansion, but whenever there is a compression, so this value will automatically become positive.
Is it isothermal or isochoric?
No, no, no. It is completely isothermal. I know you are thinking, sir, in the isothermal temperature we relate, but temperature is a constant, na? Hello?
Yeah. Yeah. Oh wait. So yeah. Okay. Okay. Because I
Temperature
just
is
recognize.
no, no, no. If temperature is constant, so not, so temperature will remain constant. So you can't say T1 and T2 because it is fixed. So if it is fixed, that's why you write only T because temperature is constant.
Oh, that
So
makes
that's
sense.
why volume is only changing, pressure is only changing. Got it?
Yeah.
When volume remain the constant, so you will not see V1 and V2. You will see only V and that become the isochoric. Got it?
Yeah.
Okay, that was that minus is representing that it was the expansion case. Like gas was expanding. That's why the piston is moving little bit above. But suppose if there is a compression, then it will automatically become positive. Okay. So when there is a compression, when you are applying some force, you are trying to compress the gas, then this complete equation will become positive. Okay.
Why? Why can't it be the
Sign,
other way
sign changing, like it is just simple physics. If you are going this side, it is positive. If you are going this side, so it become negative. Simple. So if gas is expanding, so it will come in negative. But if you are trying to compress that, it become positive. Simple. Fine.
around? Yeah.
Okay. Work done, I have already told you the basic formula for the work done is equal to, if it is the expansion case, so pressure into change in volume, and change in volume dV. Change in volume always V2 minus V1 na, final minus initial. Remember the formula of work done as well. I told you ना this formula, see here, मैंने लिखा था ये देखो. Work done is equal to P into dV. dV मतलब what? What is the meaning of dV? dV means
Change in
final
volume.
minus initial, that small change.
Yeah, change in volume, right?
Yes, change in volume, dV, delta V. So this formula is, I guess it is clear to you.
Yeah.
Okay, okay. So remember always whenever there is a isothermal means when the temperature remains constant. So the formula would always be minus 2.303 nRT log V2 by V1. Remember always. Okay. Now, okay. So it is what was about the work done. But now if I talk about the heat, what is the meaning of the heat? What do you mean by the heat, Vishnu, if I ask you? Can we say it is a mode by which heat can be exchanged between the system and the surrounding? It is something, na? It is that mode of energy. Like whenever you are making a tea, whenever you are making a coffee, so some amount of heat is going to the surrounding as well, na? Are you there?
Yeah, here.
Okay, okay. So it is the mode in which energy is exchanged, energy is exchanged between system and the surrounding. Okay, it is represented by the Q. Remember always, if heat is getting absorbed, if heat is absorbed by the system, remember, if heat is absorbed by the system, it is called positive. But if heat is evolved by the system, evolved, heat is evolved by the system, then it become Q is equal to negative. Negative. Remember, and the unit is the calorie. Unit is
Oh,
calorie. Okay. So
calorie.
yeah. So 1 calorie is actually equal to 4.8 joule. Okay.
Isn't calorie like the amount of energy it takes to like raise 1 gram of water to 1 gram, like 1 degree Celsius?
It's not about the degree Celsius. Just calorie is a unit of energy, and you know it in our body. We are losing some amount of energy as a heat. हमारी body से we are releasing heat continuously, right? हमारी body से heat
Yeah.
निकलती है. We always
Yeah.
release. That's why in winter we feel cold, because we are releasing the heat. So automatically we are becoming colder. That's why we try to maintain the heat. We are not try to lose the heat. We shrink our body. Okay. Yes or no?
Yeah. Right.
Okay. So this is about the heat. So now, okay. Firstly, I'm just going to tell you the laws of thermodynamics. So it is the first, I mean the zeroth law of thermodynamics. Zeroth law of thermodynamics. Very simple law. Okay, you should know there is a adiabatic wall which doesn't allow anything, and there is a dithermic wall which allow everything. So suppose if there is a room, and if there is another room, and in their room there is a like a dithermic wall, like they are not allowing anything. It is A, it is B, and there is no exchange. So if there is no exchange, so some amount of heat is there, some amount of heat is there in the B. But if you allow here, suppose, get o- ye- if you are just attaching that, so here is a what, here is a conducting wall actually. You can say dithermic. Things can be exchanged. It is C. So just tell me, Vishnu, can A and B directly exchange heat?
No.
No, but there is a dithermic wall between the A and C. So A and B can exchange the material, yes or no?
Yeah.
So it means A and C are in thermal equilibrium. They can exchange the heat, they can try to maintain the constant temperature. So there is a thermal equilibrium. Equilibrium means they have both similarities, equality. So if A and C are in thermal equilibrium, obviously B and C are also in thermal equilibrium. They are trying to exchange the material.
Yeah.
So if A and C are in thermal equilibrium, B and C are also in thermal equilibrium. So A and B will also be in thermal equilibrium, yes or no?
Yeah.
Obviously. Suppose Vishnu, it is like you, and this is my name Sagar, and suppose there is another friend Aditya. Suppose Adi. Okay, fine. But Vishnu, suppose I'm not talking to you because I'm very angry to you and you are also very angry. So we are not talking to each other directly. But yes, Vishnu, you are telling everything to Aditya, and I am also telling everything to Aditya. Now Aditya is telling my everything to you, and Aditya is also telling everything about you to me. So just tell me, I know everything about you, yes or no?
Yeah.
Just because of Aditya. And you also know everything about me because of the Aditya, right?
Yeah.
Aditya is working as an intermediate. So finally, without talking to each other, we both are exchanging this stuff, isn't it?
Yeah.
So this is same thing happening in the zeroth law. So if A and C are in thermal equilibrium, B and C are also in thermal equilibrium, then definitely we can say A and B are also in thermal equilibrium, yes or no?
Yeah.
If A and C are in thermal equilibrium and B and C are also in thermal equilibrium, then obviously we can say A and B are also in thermal equilibrium. So it means heat can be exchanged from one part to the another part. This is your zeroth law of thermodynamics. Very simple it is, right?
So zeroth law is A and C.
Zeroth law is simply whenever you are exchanging the heat, so it can transfer to the other one as well, in which there is a dithermic wall, because dithermic wall allow the exchange of heat, but the adiabatic wall doesn't allow. Okay.
Whenever heat needs to be exchanged.
Yes. Whenever there is a dithermic wall only. Whenever there is a dithermic wall, it will exchange only between them. Adiabatic wall doesn't allow the exchange of heat.
Whenever there is a dithermic wall.
A has both dithermic and adiabatic. This is adiabatic wall and this is dithermic. So it is exchanging downward, not to the right side. Very simple it is, very simple. Fine, got it?
One sec. I don't think I know I understand the law, but I don't know how to put it in simple words.
Zeroth law of thermodynamics you didn't understand.
No, I understand it, but I don't know how like what to write.
You have to write only this thing. If a one condition is in equilibrium with the other condition, like A and C are in
Oh.
thermal equilibrium and B and C are also in thermal equilibrium, then we can say that A and B are also in thermal equilibrium, although they had the adiabatic wall, but still A and B are connected. Got it?
Yeah.
Like nobody can't say like A should know the meaning of B and B should know the meaning of A. Why? Because they have a strong concrete walls. But because of C, A A is aware of everything about B and B is also aware of everything about A. It just think it is a society, like it is a like three families. Okay, A is not talking to B, B is not talking to A. But A is talking to C, B is also talking to C. So can we say A and B are also talking to each other indirectly? Indirectly because of C? I guess you are not understanding what I'm saying.
No, I understand. I'm just writing it down.
Oh, okay, okay. So what do you mean by the zeroth law of thermodynamics?
If A and C are in thermal equilibrium and B and C are in thermal equilibrium, A and B are also in direct thermal equilibrium.
Okay. Okay, fine. So that was about the zeroth law of thermodynamics. Now we are going to study about the first law of thermodynamics. So first law of thermodynamics is actually says that the total energy of the system remain always constant. And now what is that total energy? So the heat and the work done. Heat plus work done it actually contains. See. The first law of thermodynamics means the total energy of the system. If you are not doing anything, it will remain constant. Total energy of the system. This is the first law of thermodynamics. System is always constant. But if you are doing something, then it will get changed. So it means there is a change in the internal energy. So that change, that delta U should always be equal to Q plus W. You had definitely apply some energy. There may be some heat, and because of that heat, it can do some work done as well. So that is how, like this is the formula which is coming from the first law of thermodynamics. Like delta U is always equal to Q plus W. Okay, remember.
System is always in equilibrium unless a change is introduced.
Yes, you can say that. Yes, absolutely. Until or unless you are not giving the heat, okay, so it will not do the work done. But if you are doing some change, then definitely it will also do something. Okay, definitely. If it's just tell me, suppose if I say if I have a phone, if I have put there, so it will remain there. But if I try to do something, then definitely it will move to some other place. Right?
Mhm.
Okay. So this is all about your internal energy.
Wait, what is U, Q, T, and Q and
Oh,
W?
okay, okay. I told you na, it is because you are now you are doing something to system. So obviously you are changing the internal energy na, internal energy.
Hmm.
Suppose if you have a water in a vessel, so it is energy constant. But if you're trying to give the heat, so if you give the heat, so it will boils and it will come above, and it can drop the drop the plate as well if you put above that.
Yeah,
So it has done work done na, so Q plus W. So this is the you have changed the internal energy na, delta U.
yeah.
So it means always the delta change. The change in internal energy is always equal to amount of heat which you have given and the amount of work done he has done, or he or she, or like it is. Okay. So delta U is always equal to Q plus W. Remember that.
Hmm.
Okay, fine. Any doubt if you have, then you are most welcome to ask.
So W is work, right?
Yeah, W is work. W is
And,
work. Yes,
and
yes.
and Q is heat.
Yeah, Q is heat. Q is heat. Q is heat and W is work. So delta is U is always equal to Q plus W.
Okay, got it.
Okay. Suppose if I say if I am giving you a question, okay, and suppose if you have a 5 liter cylinder, 5 liter cylinder you have, and that cylinder actually was containing the 10 moles, 10 moles of gas, okay, and its temperature was 20 degrees Celsius. But suddenly what happened? There is a leakage. So, and the gas is escaping from that leakage, and this cylinder just got empty. Okay, now there is no gas in that. So they are asking if the atmospheric pressure was 1 atmosphere. So if the atmospheric pressure was the 1 atmosphere, okay, so can you tell me the work done? How much work done has done? How much work done is actually done by the gas? Because if the gas is leaking from the cylinder, so it is a case of the expansion definitely. and
Yeah.
gas is not coming back, it is just going. So obviously which formula you will apply? So you will
Pressure into
apply
volume.
uh, yeah. So work done is actually, so it means pressure to volume, but pressure you know it, but they haven't given you the V. So what should you do that?
Um,
Hmm. Actually, see, initial volume and the final volume. Actually, you have to find out the delta V.
oh,
So how
five
can
liter cylinders. Okay.
oh, 5 liter is the initial one, right?
Yeah.
5 liter, but now the final one you don't know, na?
Yeah.
So see what I how to solve such type of questions. So initial volume is 5 liter, V initial. It is 5 liter. Temperature is 27 degrees. So what is the final temperature in Kelvin? 300 Kelvin, because it is 27 degrees Celsius, na? So to
Mhm.
convert into Kelvin, we have to add 273.
Yeah.
Always take temperature in Kelvin, not in Celsius. Okay, it is not valid.
Okay. Okay.
Okay, but we don't know the what is the final volume, because because the formula is minus P into delta V.
Okay.
So minus P we already know, P is 1 atmosphere, but the delta V we don't know, because we need to know the final volume. So we can say PV is equal to nRT, yes or no?
Yeah.
If PV is equal to nRT, so we can find out final volume. nRT upon P. So N is how much? 10.
And
R constant, R is a constant, its value is fixed 0.0821. 0.0821.
what is R again?
R value is 0.0821. It is the gas constant always.
Okay. Okay. Okay.
It is
And then
a
T temperature constant.
is temperature, it is the 300.
Okay.
So
Divided by five.
pressure is 1. Pressure was 1,
Oh. Oh, one. Yeah. Okay.
1 atmosphere.
Oh, okay.
Okay.
I didn't do that.
So what is the final volume? Can you just tell me?
Um.
Definitely, final volume should be less than the initial one, because initial volume was completely filled.
Yeah. So 300. So that's 3,000. Like
Mhm.
two five. Like 2 4 something. I don't know.
Yeah. 246 something.
Yeah.
246 something later it is coming. So initial was 5, like initial volume was how much?
246. Oh, 5 liters.
Oh, okay. 1 second, 1 second. Initial volume was the 5 liter, and because it was inside the container, and when there is a leakage, so this gas will occupy a higher volume or lesser volume. Tell me. Whenever
Lower volume.
no, Vishnu. It is a case of leakage. If there is a spray, or if there is a cylinder leakage, so
Oh, it goes from lower concentration to higher concentration.
yeah, so that gas will occupy more volume or less volume?
More.
More volume. Why? Because it will expand, it will reach, it will cover the entire area, right?
Yeah.
Okay. So it means that will occupy a larger volume now. So it means V to V final volume we have find out of the gas, and this is the initial volume. Now can we put that into this formula?
What?
Can we find out the final work done? Because P you already know, and delta V you can find out. Fi Final volume minus initial volume. Vishnu, this is your
Yeah.
initial volume. This is
Yeah.
your final volume. So can you find out the delta V?
And you can subtract it.
Yes. So delta V is how much? 246 minus 5. So you will
241 liters.
241. Okay. And so yes, we can apply the formula minus P delta V. Minus P is 1, delta V is 241. So answer is what?
Negative 241.
241 only.
Negative, right?
Oh, yeah. Negative. Okay. But remember that was in the atmosphere. Suppose if they are asking in the atmosphere, I mean, atmosphere it was given, but if they are asking in joule, so atmosphere is equal to 101.3, okay?
Oh, okay.
101. So if you multiply it by 101.3, then it answer coming in joule.
Okay.
Work done, try to find out work done in joule, not in any atmosphere, okay?
I see. I see. Yeah.
So remember always one atmosphere is equal to 101.3. I can write there. So this is how you can find out work done. So one atmospheric pressure is equal to 101.3. You will get in joule. Fine.
Yep.
According to the first law, according to the first law of thermodynamics, can you tell me what is the isothermal expansion? I mean, what is the formula for the first law of thermodynamics?
Delta U equals Q plus W.
So, okay, very good. So now you have to solve a question for me. Suppose if I am saying like there is a temperature is 27 degrees Celsius, number of moles was 2 moles. Okay, pressure I am giving you, it is the 1 atmosphere, and the pressure, final pressure becomes the 10 atmosphere. Suppose like 2 moles of ideal gas initially at the 27 degrees Celsius, suppose at 1 atmosphere, but after some time when I compressed it, I am compressing isothermally and reversibly, and the final pressure becomes 10 atmosphere. Because
It's positive.
if you are decreasing the volume, if I decreasing the volume, compressing, so pressure is increasing na.
Yeah, since pressure and volume are inversely proportional.
Yes, so now you have to calculate the what is the heat, what is the work done, and what is the delta u, for delta u. Yes, what is the internal energy change, delta u, you have to tell me.
Okay. So we have to start off with the work done, right? We're not doing work.
Mhm. One
So
second,
I need to.
see. If it is a isothermal, right? I already told
Yeah.
you heat and temperature, they are interlinked, right?
Yes.
So one day I told you in the last class, if there is a isothermal case, so you always say delta U should be zero. Internal
Oh,
energy.
yeah.
Remember? In the
Yeah.
last class I told you. So I in the isothermal, if delta T is zero, so you will always say delta U must always be zero.
Okay. Okay. I see. Yeah.
Okay? So
Yeah.
remember. So according to first law, we know that delta U is equal to Q plus W.
Mm-hmm.
So if it is zero, so it will become how much? So can we say Q is equal to minus W?
Yeah.
Okay. So if we know the work done, then negative of that will give you the Q.
Q is heat. So yeah.
Delta U is already zero. So
Mm-hmm.
work done and Q will automatically find out if you know the work done. So
Yeah.
it is a reversible formula. So what is the formula for the work done? And it is a case of compression or expansion.
Compression.
So in the compression, we have to take negative
Positive.
sign, negative or
Positive.
positive. Very
Positive.
good. Very good. 2.303 nRT log. Okay.
Oh, yeah, because it's
Volumes are given to you or the pressures are given to you in the question.
I think we have pressures, right?
Okay, so if we have pressure, so we have to write P1 by P2 or P2 by P1.
P1, P2 by P1.
Are you sure?
Yes.
Because I remember it was V2 by V1, and when we
That
converted,
was
then
that was expansion. Okay, so it's P1 by P2.
it is not because of the expansion, it is about the Bayes law.
Oh.
Because relation is V2 is equal to V1 is equal to P1 upon P2. So
Oh,
V2 by V1 sign was there originally in the formula. So when I replace it, it become P1 by P2 na.
yeah. Oh, yeah,
Okay,
that makes
if you are
sense.
confused, I can show you.
No. I got it. We did this. We P1 V1
Yes.
equals P2 V2. We divided it by.
See.
Yeah, I
Yes.
remember now.
V2 by V1, we know the Bayes law. If I convert that, it become the P1 by P2. Okay.
Yeah.
So it is not because of the expansion and compression, it is just because of the Bayes law.
Yeah, that makes sense.
Okay. So we can write because volumes are not given to us, so obviously we apply pressure formula. P1 by P2? You know it everything. Can you try to find out? I'm already telling you log 10 value is equal to 1.
I know. Yeah.
2.303. Okay. N value is how many moles I have given? 2 moles. So 2 into, wait a second, just.
It's 1 in 10, right? Initial and
Yes,
final.
yes.
Wait, so wait, I'm trying to find out Q, right?
Yes. Just find out work done first, then automatically you will get the Q.
Okay, so W equals 2.303 times number of moles, which is 9, right?
Hmm.
9 times R is wait, R was
Number of moles 9. एक second.
it's
Ek,
10, it's 10.
no, no, no. एक second, एक second.
Oh, was it 11? I forget.
Number of mole, Vishnu. Number of moles.
Oh, it's 2. Okay, I thought it was, okay, so it's 2 times, wait, was it 0.0821?
See. Here. 27 degree I have given to you. 1 second. 10 atmosphere. So wait second. Just a second. It is
Yeah,
pressure is given to us. It is in atmosphere. And if you want to take into the joule,
times
you can take directly R 8.314.
8.314. Okay,
Yes, because we are directly finding out in joule, so you can write 8.314.
okay. And
And
then T is 300, obviously, because
yes,
Kelvin,
yes,
you know.
yes,
P1 by P2. Okay, I'm gonna have to do some math. So can I use a calculator then?
yes. As of
Okay.
now only, but in the
Mhm.
exam you are not allowed.
Okay. Mm. Oh, what? I haven't. Okay, so
Hmm.
2.303 times 2 times 8.314, you said, right?
Hmm.
Okay, so uh, W equals 11,488 log P2, P1 by P2. Log base 10, right?
Yes. It is one.
Wait, what?
Log 10 is equal to one, na? You will automatically get the log P1 by P2 or P2 by P1.
P1 by P2, obviously.
Okay. So if it is P1 by P2, so it will become, oh, okay. So it will become the 1 by 10.
Hmm?
Okay, just take log 1 is equal to, let's take it log 1 is equal to 0. Or you can just calculate it and whatever the answer is coming, you can just quickly tell.
Yeah, I got 11,488 log P1 by P2.
Log P1 by P2. Okay, very good. And okay, just suppose the log term is coming as a 1. Okay, after solving it. So obviously your answer will be 11488 joule, right?
Yeah.
Okay, so this is your work done, na?
So Q it's negative
Yes.
11,488 is Q.
So Q will be negative, so minus 11. Okay. So just by finding out work done, you have already find out Q and both of them, right?
Mm-hmm.
Very good. Yes. So this is how we can do it. Okay.
Oh,
So
cool. That's
this
cool.
is the first law of thermodynamics by using thermodynamics. Little bit typical because so many people get confused. Like work done is what, heat is what, why delta U is becoming zero when it is a isothermal case. Okay, so if you just remember these things, then you won't face any difficulty. Okay, okay. Vishnu, are you there?
Yeah, I'm here. I'm here. I was on mute. Sorry. Yeah.
Okay. So that is the first law of thermodynamics. Now I am going to tell you the very important formula, and that very important formula is delta H. Like whenever there is a reaction and the reaction is happening, okay, so obviously many energy get changed, so it is known as a enthalpy change. Delta H. Suppose right now my energy is 50, but suppose if I am fighting with someone and now my energy is only 10, so it means my 40 energy is utilized in fight now.
Mm-hmm.
So it is known as a delta H. So delta H is equal to delta U. Delta U means internal energy plus work done. And work done, you actually you have to say work done is equal to nRT. Like work done is equal to PV.
Mm-hmm.
पता है अभी आपने पढ़ा पीछे, P into delta V, and delta V and P delta V is also equal to nRT na, according to
Yeah.
given equation. So
Yeah.
I am directly writing nRT in terms of work done.
Mm-hmm.
So this is a one other formula as well you need to remember, like delta H and delta U. आपको हमेशा ध्यान रखना है what is the meaning of delta H. It is the heat of reaction at a constant pressure. At a constant pressure, remember, delta H is a heat of reaction at constant pressure, and delta U is what? It is a heat of
Internal.
reaction at constant volume. Okay, at a constant volume. So delta H is what? Delta H is a heat of reaction at constant pressure, and delta U is a heat of reaction at the constant volume. So you can also say actually it is internal energy and enthalpy. So I am writing this heat at a constant pressure. It is equal to delta H, and heat of a constant volume is also equal to delta U.
Okay.
So heat and such relation you need to remember as well. So it is another formula, delta H is equal to delta U plus delta nRT. Please,
NRT is number of moles
our
times
gas
the,
constant.
and then T is temperature, obviously. Okay.
Yes. So you have to remember delta H is equal to delta U plus ka nRT. Remember always. And delta N means it is a total number of moles.
Mm-hmm.
Total number of moles, like product moles minus reactant moles. Okay?
Wait, R is the pressure of gas, right? Constant pressure of gas.
Yes, yes. R is a yes. Suppose if I say there is a reaction, Vishnu. Suppose there is a liquid, okay, or suppose there is a gas. Suppose because we have to take the gas always. Suppose this is the three, so 3A is giving you 4A. By they are combining with something. Suppose so 3A is giving you 4A, and it is also in gas. So what is the delta N for that reaction?
Delta
Total
N.
total number of moles minus total number of initial moles.
One.
So 4 minus 3, can we say it is 1?
Yeah.
So for this reaction you have to find out the delta U.
Mm-hmm.
Delta U. And suppose I have already given you the delta H. Delta,
Yeah.
the heat of vaporization, or like heat is given to you 40.66 kilojoule per mole, and R is given to you that thing 8.3. Just take it as 8.3. If you want to find out in joule, so 8.3 joule per mole per Kelvin. Now tell me, and it is at the 373 Kelvin. So can you find out delta U? Of course. The formula is given to you, na?
Mm-hmm.
So it will go to that side, right side. Delta U. Apply this formula, Vishnu. What is the answer you are getting?
Um. Wait, show me. Wait, which one?
This above formula, just I just told you recently. This one.
Yeah. Delta H equals delta U plus delta nRT.
Yes, delta H is given to you. This one is your
Mm.
delta H.
Oh, you want me to? Okay. Yeah. A equals.
Delta N you have already find out in this reaction.
Yeah.
R you already know.
Point eight. 8.3. Yeah.
And 8.312 hota hai, but in the question they have already given to you. and T is that thing. So you find out U.
Yeah, let me just multiply everything for nRT.
So delta H minus delta nRT, you can find out the delta H then,
Hmm.
isn't it?
Yeah, wait, I'm doing it right now. Give me 1 second.
Surely, surely.
Okay, so 8.3 times 313.
Hmm.
2597.9. So I need to subtract that from delta H was where again? Oh, okay. So uh it's gonna be a negative number.
No,
Yeah,
negative number.
yeah,
Okay, एक second. We know the formula delta H is equal to delta U plus delta NGRT, right?
yeah.
Delta H is how much given to us? 40 point,
66.
but it is a kilojoule. So it is a
Oh, so
kilojoule.
thousand.
Yeah,
Oh,
so
okay.
it will become the 4660.
Mm-hmm.
Point will be removed, so it will automatically become joule per mole. Okay, so 40,660. Delta U we already don't know. Delta N is 1. R is 8.314. You already know that. Temperature is already given in Kelvin, 313. So you can find out the delta U now.
Mm-hmm.
It will become something 37559 joule, I guess.
Yeah.
Are you getting the same thing?
Mm-hmm.
So this is how you can just solve the question by first law of thermodynamics, and the other formula delta H is what? It is enthalpy change, energy change of a reaction
I
before
got
the
like
re
I got 38063, but again, it's
okay.
what
What is the meaning of delta H, Vishnu?
the change.
Yeah, change in energy. Okay, if there is
Yeah.
a reaction, so before the reaction and after the reaction, how much energy is there? Okay,
Yeah.
and delta U is internal energy change. Delta
Yeah.
NG is how much? Delta NG.
NG is 1.
No, for this reaction it is 1, but actually what is delta Ng?
Oh, the number of moles.
Yes, the number of moles, the change in number of moles.
Yeah, the
Pro
change on, yeah,
Total
obvious.
number of moles of product minus total number of moles of reactant.
Yeah, 4 minus 3 in this
Okay.
case.
Okay, and what is the R?
The constant temperature of gas, constant pressure of gas.
Okay, very right. So right now I am just giving you a homework, a small homework, okay? So
Yeah.
actually in reality, this is the like suppose if solid is converting into gas, so it is known as a enthalpy of vaporization. If there is a something is getting formed, it is known as an enthalpy of formation. If you are conducting a combustion reaction like carbon plus O2 CO2, it is known as an enthalpy of combustion. So we have so many enthalpies like enthalpy of solution, enthalpy of atomization, enthalpy of ionization, enthalpy of hydration, enthalpy of hydrogenation. Okay, so many
Yeah.
type of enthalpies we have like neutralization, sublimation, enthalpy of fusion, sublimation, vaporization. So many enthalpies we have. So it is your homework, you have to read out and you have to write as well if you can. Okay, it is about the enthalpy. Okay, so
Okay.
you have to study about the various type of enthalpies, like what they are.
All right.
Okay, so okay, it's all for the today. We'll meet you in the next class.
All right. Bye.
Bye bye.